Evening, everybody. My name is Jack Coy, and today I'm going to be talking to you a little bit about Spring Dependency Injection. We've already kind of discussed a little bit in this class about some of the stuff in the Spring framework, and I just kind of want to talk about where dependency injection fits in here. So dependency injection is going to be kind of right here in our core container, specifically in the core area. The core is where the dependency injection is actually implemented, and then context and beans are used to kind of put that together into something that's useful. And we're going to talk about beans and context today as well. First, I kind of want to talk a little bit about how we came to dependency injection, like the path that we took to get to where we are. So it kind of started with this concept of inversion of control. If you look at my two examples below, on the left you can see how we have some class called a fan, and it's responsible for instantiating its own motor. If you see right here, it makes up its own motor, where in this scenario the fan is not responsible to create its own motor, but rather the motor is given to it. Okay? This is the concept of inversion of control. We want to remove the control from your classes, your components that you're building. You don't want them to have the power and ability to be creating these new motors. Instead, you would rather just say, hey, these are passed in. So we could do this today in this whole concept without dependency injection and just build all of our components with constructor arguments. All right, buddy, no. But dependency injection is going to help us out here. So a Spring container manages the full life cycle of your components. No longer are you going to be required to be building your components, constructing them, passing in all the things that they might need because you've made them be required to be passed in. Instead, the Spring container is going to go ahead and take that for you. Oops, excuse me. So in this diagram we show that we have our plain old Java objects that you're writing, and then you're going to put those through a Spring container. We're going to talk about the two types next. And the metadata that you provide, the configuration that you provide, combined with your POJO classes, is going to give you your ready-to-use, fully functional application. Okay. So go over this briefly. It's not very important, but there are two types of Spring containers. There's the Spring Bean Factory container. It's very simple, basic dependency injection. And then there's the Spring Application Context container. This is going to include all the same functionality as the Bean Factory, and for today's purposes we'll be using the application context because unless you have any good reasons not to use it, why not? Some of the reasons might be speed, for the record. Bean Factory is a much more lightweight container, but it's not too bad in the application context either. Okay, so let me shrink myself here. Let's talk about beans. When I first heard this, I kind of was like, oh no, this whole new concept. What's going on? Beans aren't actually that complicated to understand. I'm going to read you this definition because I felt like it's actually a pretty good one. A bean is an object that is instantiated, assembled, and otherwise managed by a Spring Inversion of Control container. These beans are created with the configuration metadata that you supply to the container. Okay. So in the end, a bean is just a configured concept of one of your POJO, one of your plain old Java objects that you've made, right? So the configured bean will then be provided by whatever container you have set up to do this. The container will go ahead and instantiate the bean, inject any sort of components that it's necessary to need, and it will be able to give it back to you ready to go. So we're going to talk today about a few different ways that you can configure your beans. First, we're going to jump into how you can use XML to configure your beans. We're going to be using a class path application context for XML. Whoops, excuse me. And the other option is to not be using XML, but rather do your bean configuration using classes. So there's kind of two ways to do this, but both are going to require at least some annotations. and we'll talk about kind of pros and cons between these two different styles. Start out with talking a little bit about how this XML config file works and show you some code. Alright, so we have the class path XML application context, which is our container, our Spring container. It's going to be loading its configuration from the Beans.xml file located here, and I'll show you that in a second. And we're able to say, hey context, give me the bean for fan. And it'll return us a fan, which we do have to cast, and we'll have that fan here, and we can immediately start using it. And this fan, just to give you a quick look, it's going to require a motor in order for it to work, right? So we have this set motor method that it's going to be called by our container when it's setting up and instantiating this fan for us. We'll talk a little bit about the motor here more in a second. Okay. So our Beans.xml file is not too complicated. Ignoring kind of everything that's happening here and just noting that you're inside of a beans tag, we can define all the different types of beans we have. Okay. So I've said that we have a bean called fan. Here's the class's location, Spring tutorial and fan. And it has a property called motor. If we pull up fan here again, it does have a property called motor. And I'm saying that that property motor should be dependency injected with this electric motor right here. So basically what's happening is that our main app has this context, loads the information. When I call get bean, it goes, okay, I need to get a fan. And it looks back at this beans file to determine how to give me the fan. It's going to set up the property motor on fan with electric motor, which is defined here. The electric motor does not require anything, which is why it doesn't have any configuration information in this Beans.xml file. It just can be instantiated. No problems. So our fan, if you notice, there's kind of some sort of implicit thing going on here. I have motor, and somehow our container knows how to call set motor. Well, this is done through the fact that I'm using correct naming principles here and saying this function's name is set motor. If it was, say, set motor something else, it would not work for us. So the container automatically knows to call this and populate it with this motor, and then we're on our way. So if I go ahead and kick this off, and we'll talk about what this kind of shows us here, ignoring the red, which is information, we say that we're inside the electric motor's constructor. Good. We need the electric motor. And then we're inside the set motor method, which is inside of fan here. So we've set a motor. And then when we call start from the main app, sorry if I'm jumping around a little too fast here, when we call fan.start, that is going to call the motor.spin, whichever motor has been given to it. And in this case, it's our electric motor. Cool. All right, I don't want to overdo it here. So let's go back and take a look. So we also have the configuration class that we can use. Real quick, I'm going to switch over to our class config. So there's going to be two ways that we can do the class configuration. So popping over to my example, I'm just going to refresh real quick. I've just checked out a different branch that I've been demoing. So the difference here is we're using our Annotation Config application context. And within that, we're saying, hey, instead of going to some XML file to identify what's going to be going on and what our configuration is, instead, I want you to look at this Dependency Injection configuration class. Okay. Let's pull that guy up. All right, so this class basically replaces the information that we had in our bean file from before, and it allows us to say, okay, now if I want to have a fan, I can come here, and I've marked this method as providing a bean to our container. So our container knows that this provides a bean. So if I go ahead and ask for fan class, it can go look at our configuration file and say, oh, okay, I'm going to go there and ask for a fan. So I'm going to call get fan. And that's going to turn us a new fan. Okay, all ready to go. So let's give a try on this and see what happens. Okay, cool. Now you notice something maybe, that when I made this new fan here in this dependency injection configuration, I did not provide it the motor that it needed. So how did it get that? If you notice, we instantiated an electric motor and a gas motor as well, and then we called set motor. And when we actually spun the fan, it was the electric motor doing the work. Okay, how did this happen? So a lot of what this configuration outside of using the XML is going to entail is a lot of these annotations. In this case, we have auto-wired set up. Auto-wired is an annotation from Spring that tells Spring's container to automatically wire up this class and provide it what it needs, or what it's asking for in this set method. So it has a motor field and we have a set motor method, and we are asking for an electric motor in this method. If we instead change this to just motor, we're going to blow up because it doesn't know whether or not, let's see if it gives us a good error. Let's see, exception is could not auto-wire method, no qualifying bean of type motor is defined. Expected single matching bean but found two. Oops, had a gas motor and an electric motor. Perfect. That's the exact problem. Here we're saying that we want to hold on to a motor, but we don't know which type it is. And in our set method, we're saying ahead of time, we're actually going to want an electric motor, but we're going to program to an interface. So we're going to save that motor as just our motor interface, really boring class, to be used later. Cool. So AutoWire knows to send it an electric motor before it's done. Okay. Oh, one more quick thing here. Our Beans.xml does still exist, but it's dumbed down. It's not actually very important anymore. Now we're just saying that our context is going to be using an annotation config instead of loading from this file more bean configuration. You guys how you can use the configuration class to provide your beans. And we talked a little bit about annotations, but the third kind of way that you can configure your beans is if you do this through pretty much solely annotations. So coming back to our main app, this is going to look identical to the last example. If we pop over to our dependency injection configuration file, you'll notice it's a little more empty than it was before. If you remember, we had a bunch of methods in here like get electric motor, get gas motor, get fan, and those were helping us those are helping the container get the beans for us, right? So what is new is this new annotation that says, hey, container, since this is a configuration file, which I've marked it by this annotation, I would like you to look for components in this package. Okay. So instead of the configuration file itself providing explicitly beans for the container to be using, we now have these component annotations above each of our motors. And this tells the container, hey, these are going to be beans that we would like to be able to use and fetch. Same with here in gas motor and in fan. Okay. We still have that same auto-wired method here. So let's go ahead and give this a quick run, and then I'm going to talk about a couple things about what's kind of interesting here. Let me pop back over to slides for you. So yeah, this is what I want to talk about. The scope of a bean. So I think you're all pretty familiar with the concept of scope in its generalness. And in Bean world, we have two scopes that we'll be dealing with. There are three more if you are working in a web context, but two for us today, the singleton and the prototype. The singleton is just as you would imagine for the pattern we've learned, where the singleton is instantiated once in the beginning, and that same copy, that same instance of that bean is going to be reused every time you ask for it. The prototype is the exact opposite. Every time I request a bean, I will receive a new one. Okay. So with this concept in mind, it's going to start to make a little more sense why some of these things are happening down here. By default, the scope of a bean is going to be singleton. So the reason I'm bringing this up is if you notice, gas motor is being constructed. However, it's not the one that's needed by fan. So why is it being built? Well, the answer is that because it is a singleton scoped bean, it's going to be created upon instantiation of this context. Okay? So if I were to get rid of these two things with the fan and never even get the fan, go ahead and rerun and see what we get. We are still calling the electric motor constructor and the gas motor constructor. And the reason we're calling set motor on fan here is because fan is also scoped to singleton, and it's instantiated upon startup as well. And since it requires the electric motor, it goes and fetches one. Okay. So let's explore what happens if we change the scope of this bean to being a prototype. Okay. Now I'm going to have to import scope. Let's see what happens if I just rerun right now. Okay. So if you noticed, what's missing is set motor. That's because fan is no longer being instantiated when the context is being instantiated, and thus it doesn't require a motor because it's not being built. Okay. However, electric and gas motor is still being built because we haven't set their scope. If we come back here and do the same kind of thing here as well. Okay, import this guy. Looking good. Now if I rerun, you should expect only gas motor to be instantiated. Excellent. Okay, so now if I come back to our main app and I uncomment these lines and I kick it off again, there we go. Now I see the gas motor was instantiated initially with the context, and then later when I wanted to instantiate the fan, I saw that it required an electric motor, so I built that, and then I set the motor, and then we do the spin. Okay, so if I were to do this again and have another fan, maybe fan 2, and I do fan2.start, go ahead and kick this off, you're going to see that 2 fans were set motored and 2 electric motors were created. Perfect. It's exactly what we expected. And they're both spun. Cool. Alright, there's 2 more things I'd like to talk to you guys about today. I'm going to try and get to them quickly. Let's go ahead and remove my fan 2. I'd like to talk about just quickly the 2 types of dependency injection. Pretty simple. We've been using the setter-based dependency injection with set motor, and there's also just the constructor-based dependency injection. Just give you a quick example of that so that you know I ain't lying, it's working. So instead of having set motor here, I want to make this my constructor. So I can say my public fan constructor, and this will be inside fan constructor. Now notice I still need to keep this as an electric motor being passed in, otherwise it has no idea what type it's going to be given. If I wanted to make this just motor, I wouldn't be able to just use the basic auto-wired annotation. That you can add to this annotation the exact specific type you'd want. Also, it's probably a little cleaner looking in the XML file. or back to the configuration file up here, you can specify it there as well. But since we're not doing it that way, we have electric motor as the requirement, and it gets passed in this way. If we pop back over to our main app, you can see that works as well. Cool. So this is kind of the overview of how all this dependency injection stuff works. Kind of a back and forth pros and cons here quickly about using that Beans.xml file versus using these. One of the things that has to be taken into consideration when you get a large project going on is that your Beans.xml file is going to be massive. You're going to have hundreds of beans, and at that point it can be pretty overwhelming to take a look at that Beans.xml and try and understand exactly what's going on in your program. So you find that a lot of people in software development today are using annotations right inside their class because it provides a lot more clarity. Once I come to this component, I know right away how this fan is treated. I know that every single time I ask for the fan, I'm going to get a new one. I know that I'm dependency injecting this motor. So all these things are a little more clear and right up front. They can get a little in the way, but I don't think it looks too bad. If you need a little bit more control, sometimes your configuration file can help. You can mix any of these styles, by the way. So we can do a little bit here and a little bit of the annotation separately, and the context will be able to figure things out. Cool. All right, so one more thing I want to bring up today. Just, whoopsie. We can also inject collections. So your standard Java list, your sets, maps, and props. Props is probably a new thing for most of us, and that's going to be just a map where both the key and the values are strings. So let's see here. Okay, right. Sorry about that. I keep changing stuff and can't check things out. All right. Cool. Let's refresh. So things are a little different, and I decided to show this one by using the Beans.xml file. Looks a little more understandable, I think, right off the bat. So I have this new file I call My Collection. My Collection has a fan list, a fan set, a fan map, and a fan prop for properties. Okay. It has setter methods for each of these and get methods. The get methods print them out as well. That's all that's going on here. I'm using that class path XML application context again, pointing to the Beans.xml file. And I request My Collection, which is defined in the Beans file. I'll go right back to it. And then I ask the collection for each of its four things, the list, set, map, and prop. Okay. So in Beans, I define My Collection, the ID here, matches this main app request. And I then list out all of the properties inside this bean. Oh, let me see if I format. There we go. So these properties look inside, they're inside this bean. And I have four of them: fan list, fan set, fan map, fan prop. Okay. And the list is, as you would guess, blue fan, red fan, green fan, green fan. Notice you can have two of these values. I do the same thing for a set here, but as you remember, sets are unique. So when we print these out, we should only see one green fan. And notice my syntax here in the bean file. I'm defining this ahead of time as a set and this ahead of time as a list, so that the collection can go ahead and transform this appropriately ahead of time and just give it the list object or the set object or the map object. Here I want to do something a little more fun than just a string, and I have a key for electric and gas, and then I chose a value reference to our actual electric and gas motor beans. So those are defined up here, and those are our electric and gas motor classes. So we'll see how those look. And then our fan properties, which are pretty basic and simple, but worth mentioning. Properties are useful when you are literally just setting properties, right? You don't want it to be thought that there could be anything in here but strings. It's just a kind of a common practice. All right, let's see what we get. All right, so yep, we are back inside set motor. I think I took out the system prints for electric and gas motor constructors, so that's how they're not there. And our list element has blue fan, red fan, and green fan. Missing the second green fan in our set, of course. Maps pointing from electric to an instance of the electric motor. Same going on for the gas motor. And then we have our 1 fan, 2 fan, red fan, blue fan. All right. Well, hopefully I gave you guys a good overview today on the basics of what dependency injection is. You know, it really is part of the core of the Spring framework and pretty important to understanding and using the rest of the Spring framework successfully. So I think that if you were going to start things out and you were unsure about yourself, start here, try and figure out how these things work, and move your way up to exploring some of these other options, maybe adding in the web plugins and the data access plugins, once you kind of get a feel for how Spring is helping you out. It's always good to keep in mind the separation between what Spring is doing for you and what is already built in for you in Java. All right, thanks for listening.